Hello, I'm Levi Glass, and this is our bottle line project in MET 284. And
And my name is Stephen Sutton. We'll be going through our code. As you can see, our simulator is currently running. That just makes it look nice and just makes it easier to kind of run through. I'll stop it before it gets too out of hand. But Levi, you go ahead and explain the first rung here.
yeah, our first rung is a rung that keeps the conveyor running. So it keeps the run lamp on. And what happens is you press the start button, and it passes power through the entire rung, and it keeps a seal-in circuit that can be broken by the stop button. If the stop button, which is uh, if the stop button is pressed. And now for the next set of rungs, that's bit shifting, which Stephen is going to explain more about.
So in bit shifting, we have the first input on rung one, which that is the bottle exists. And essentially, what that does is when that turns on or passes power, it'll begin the shifting of bits, or at least turning them on, and then for every single time it activates, it'll shift those bits over. So first we'll start with the first one, which is uh, bit word 2, and that essentially starts at bit 0. So as this turns on, this pretty much ensures that there's always a bottle in place. Bit the word bit or word 4, its bits will control the tall bottles as it passes the limit switch here. This will track the larger bottles. This will allow us to properly know when the tall bottles are under the fill station, when they're over the diverting gate, and when they're out of the capper. The third rung is for scrap. That is for word 6. And of course, all of these actually take up 2 words from the length. That means that the first one actually takes word 2 and 3. The second one takes word 4 and 5, and the third one takes 6 and 7. So what we've done here is for the control, we'll kind of let me do that. We'll go down here to the main conveyor output. So that's essentially turned on when the run lamp is on, the capper is off, the fill tube is off, and the scrap conveyor is not running. There would also be more commands here to allow the conveyor to index, but we were unfortunate to not get that far. So I'll go ahead and pass it off to Levi here to kind of go through the bottles.
Thanks. The next rung 003, is diverting tall bottles. And as you can see on the very left input on that rung, we have it saved as a bit so that when that bit turns to 1, it'll pass power. And we also have it set at a latch so that way it stays on after the first bottle goes through. A lot of times running the simulation, we have this problem where it starts up, counting up the small ones, but once it gets going, it only counts the large ones. And you probably saw on the simulation itself that it was working the way it should. And our next couple runs are when the scrap goes to grinder, which is where I'll let Stephen take over for a second.
So when the scrap goes, we'll see that here that uh, the word 6, bit 8, that is the location of the scrap gate right here. And when the bit shift has acknowledged or that bit has turned on, this will allow power to pass on that rung, allowing the scrap gate to turn on, which then will turn on the limit switch, will begin the count process of the of the scrap bottles. So that's what we've used to solve that particular problem. I'll go ahead and go to we'll go ahead and go to the scrap conveyor. Levi, you want to take that one?
Yeah, if you want to scroll down just a little bit. So with the scrap conveyor, what we have going on is when a when the counter gets to a certain point, which is the /done bit, and there's a box, it will go all the way to the right where the outputs are, where it will latch the scrap conveyor on. It'll reset the counter above it, but that has to be unlatched by a condition, which the condition turns on if the scrap conveyor is on for so much time, according to this timer on delay, and if the box sensor is in the if the box sensor is set up the right way, it should unlatch whenever the next box is in place. And our next station is the fill tube station, which I'll hand over to Steven unless he wants to make any more comments about the boxes.
Yeah, so on the conveyor, I realized one of the issues we were having was we didn't have a third instruction here that actually associated the timer. So the timer was not there to actually turn off, the belt. So that's one of the reasons it kept going. So that was a mistake on our part. If we just add that third instruction, we could easily control the conveyor belt. But unfortunately for this particular presentation, we'll just have to live with that fact. But no, we did catch it. So we'll go to the fill station now. So in the fill station, we have our small fill. So currently, we have the limit switch to that fill sent to the fill output, which would actually not be needed. So we can actually take that out because that will not actuate until the tube actually turns on. So we could leave that out. However, we do have a bit controlling the location of a small bottle, and we have a bit that controls that there is no tall bottles at the location, and we have a bit saying there's no scrap there. And the fact that the fill tube is not on will allow the fill tube to turn on, give it a quick charge, and allow the fill tube to retract back. Same thing goes for the large fill. Again, we don't need the limit switch, but we will want to make sure that there is a tall bottle there. And since that's the only thing we're concerned about, we could add a scrap to make sure that there is no scrap there. And we could add a invert command, making sure that there is no bottle or short bottle there. And the same goes for the fill tube. When the fill tube is quickly turned on and turned off for a quick discharge, allowing the process to go nice and smooth. Oops. So I'll hand it off to Levi for the bottle count, unless he wants to add.
Yeah, I should be able to. I'll go over the bottle count. What we had working, Stephen, if you want to make the simulation itself a little bigger so they can see. Yeah, spread it to the right.
There we go.
That's good. That's plenty good. So with the counters for all of the small, large, scrap, and boxes, we did get the box counter working. If you would scroll down to that. Oh, if you would scroll down to the box counter itself.
Sure.
All right, so what we have is we have the box sensor at rung 19. It latches on, then the output at 02/14. It also activates a counter with a preset. It also activates a counter, which the accumulated value of that counter goes to the TOD command, which raises it up every single time. And as soon as that rung goes through, it also unlatches at rung 18. We were having a little bit of trouble understanding exactly how this works ourselves, but we do know that for the box counter, it has been working. On the other hand, we kind of encountered a glitch where the other counters, for some reason, if you scroll back up, the ones that count the scrap, the large, and the small bottles, all of those counters, they weren't working the way they should be, even though our box counter was. And so I think I'm going to let Steven finish off a few things here real quick.
Yeah, so we do have some counters. I'm not sure what the issues were. Um, they do work. One thing we did find out was that that these outputs work best when they're only turned on for one scan. We probably could have used the one side rising command, but we haven't. I had some difficulty trying to understand how well that really works, so we ended up using just latching and unlatching commands to turn off the outputs and turn off the outputs. So with that said, this was a fairly difficult project. It was still fun. We learned quite a bit, especially about bit shifting and bit controls. Still a little hazy on it, but the work we have put into it gave us a much better appreciation for bit control, using bits to turn on and off inputs and outputs, the capability for it to track, and how important it is to the PLC. Not only that, but then understanding the processes alone made coding a little bit easier. We definitely spent plenty of time trying to understand the processes, what we need to do, and how the code would relate to that. Unfortunately, we just didn't get very far. Uh, but this is not something I would not consider a failure, as we were able to get to actually do something without a whole lot of assistance, just more some understanding from Professor Sisk. Uh, we learned a lot, so I can't uh, I can't say it was all bad. So yeah, it was a lot of fun. Levi, you got any final words yourself?
No, actually, I don't have any final words.
With that, we greatly appreciate it, and MET 284 was a very fun class, and we hope people enjoy it again. And I think this is a very good challenge for upcoming students as well. So we'll leave it here. Have a good one.